Hello. Now I shall discuss about how to perform comparisons. Now, in order to do comparisons, we have discussed into the last video about that we have to distribute the elements. Either we have to distribute the elements as the one element per process or the multiple elements per process. Now, into this one element per process, there is a particular operation with the name parallel compare exchange operation, and onto the other method multiple elements per process, there is another operation which is having the name as which is parallel compare split operation. Now we have to differentiate in between both of them with the help of the examples. Now, in the case of the one element per process scenario, suppose that there are two different processes. Sorry. Suppose that there are two different processes, process Pi and the process Pj. The process Pi is having the value Ai and the process Pj is having the value Aj, and this is the scenario at the step 0 or step negative, whatever you want to say. We can be that we can be able to refer in this way. Now, in this particular step, into the next step, the process Pi will send its contents towards the process Pj, while the process Pj will send its contents or the value stored at its location towards the process Pi, such that you can be able to observe into the step 1 that Ai is being transferred by the process Pi towards the process Pj, while Aj is transferring the value from its end towards the process Ai, uh, towards the process Pi. Now, after this scenario, into the step 2, we are able to observe that the process Pi is having the value Ai as well as Aj. Similarly, the process Pj is having the value Aj as well as Ai. Now, now we have discussed earlier into the old video that since the value of I is less than j, since the value of I, we have assumed that the value of I is less than j. In that case, the smaller value will be retained at the process Pi, while the larger value will be retained by the process Pj. And since only one element should be stored at each of the process, so the smaller value will be there into the process Pi, while the larger value will not be sent back towards the process Pj, but it is being simply discarded, or it has been removed from the buffer at the process Pi. Similarly, at the process Pj, whichever the value which is maximum, that maximum value is to be retained, while the minimum value is being discarded or being deleted from the buffer of the process Pj, such that at the completion of this step third, that the minimum value will be saved at the process Pi, while the maximum value will be saved at the process Pj. And in this way, this parallel compare exchange operation will take place. Now, into the parallel compare split operation. Now again, we have the same scenario that there are two different processes Pi and Pj which are taking part into this particular compare and split operation. Here, uh, here we have again assumed that the value of I is less than j. Now, uh, this now into the next step, the process Pi will send its contents or the values towards the process Pj, while the process Pj will send its contents or the values towards the process Pi. In this way, these five values will be transferred towards the process Pj, while these five values are being transferred towards the process Pi. But one thing is to be noted that before these five values are being sent by the process Pi towards the Pj, and also these five values are being transferred by the process Pj towards the process Pi. These values are to be first sorted into the ascending or descending order with respect to the requirement of the programmer. at the process pi, and then it is and then this exchange operation will take place in between these two different processes. So first of all, uh, these values which are in some random order are to be sorted at the process pi. Similarly, the values which are being at the some random order at the process pj are to be sorted, and then they are being transferred towards the process pj and as well as process pi. Now, now the process pi will receive both will receive the buffer, which is the values which is being sent by the process pj. In the same way, the process pj will also receive the value at the completion of the step 1. Now, into the next step, the process pi will take place, will sort the values, at its end for these values. It will sort those values at its ends such that into the step third, the process pi is having the values into the sorted order as 1 to 6 up to the 13. Similarly, at the process pj, the values 1 to 6 up to the 13 are being arranged into the sorted order. Since we have assumed that the subscript I is lesser than the subscript j, then the smaller values are being retained. The smaller values are being retained by the process pi, while the larger values are being discarded or being deleted from the buffer of the process pi, uh, and hence they are not being sent back towards the process pj, but they are being simply discarded, just like the parallel compare exchange operation. Similarly, with respect to the process pj, the larger values are being retained by the process pj, while the smaller values are being simply discarded, such that after this scenario, that the into the step 4, the process pi is having the value 1 2 6 7 8. You can be able to observe that it is initially having the content as 1 6 8 11 13, and now it is having the not only the value 1 6 and 8, but also the value 2 and 7, which are being transferred from the process pj. Similarly, at the process pj, it is now having the values 9 to up to 13, where it is already having the values 9 10 and 12, and it has received the value 11 and 13 from the process pi, such that this is the final output with respect to the parallel compare split operation. Now we shall discuss about the sorting networks. Now, we shall discuss about the sorting networks. That what are the sorting networks? A number of the networks are being designed for sorting onto the parallel architecture. Um, and in those cases, it is being observed that with respect to the sequential sorting algorithms, some of these algorithms onto the parallel architecture are having the are computationally efficient. It means that the complexity of those algorithms is lesser than theta of n log n, which is being observed as the best case algorithm for the with respect to the merge sort and the heap sort. So, in the case of the parallel architecture, there are some algorithms like Bytonic sorting algorithm, Bytonic sorting network algorithm, where it is being observed that the computational complexity is smaller than this theta of n log n time. Now, these networks are based upon the comparison model. Likewise, I have discussed earlier that there are two different types of models: comparison based algorithms and the non-comparison based algorithms. We have to compare the values. So we have to compare the values with respect to independent of any other property. We have to just simply compare two values which are which one is greater. We will not consider any other property like the binary values or any other values. So here in this case, the multiple comparison operations are happening simultaneously. Um, Multiple comparison operations like the parallel compare exchange operation or parallel compare split operation, because for example, this 16 node hypercube is there. If I will assign one element onto each node of this 16 node hypercube, then I have to use the parallel compare exchange operation. If I will assign 100 values towards this node, 100 values towards this node, 100 values towards this node, and in this way 100 values towards each of the node, then I have to use the parallel compare split operation. Now 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 in between any two processes, suppose that these two, suppose this node as well as this node is taking part into the parallel compare exchange operation. Similarly, this node as well as this node is taking part into the comparison operation. Similarly, this node as well as this node is taking part into the comparison operation. Similarly, this node as well as this node is taking part into the compare exchange operation. Now in this case, now in this case, the compare now in this case the parallel compare action operation will take place, and the multiple pairs of nodes are doing the comparison as well as exchanging the values. So in this way, these two nodes are communicating simultaneously, as well as these two nodes are communicating simultaneously, as well as these two nodes are communicating simultaneously, as well as these two nodes are communicating simultaneously. So in this way, multiple nodes are executing the same set of data simultaneously. So in this way, this thing is efficient. Now, there is an important component of the sorting networks which is being named as the comparator. The comparator is an abstract device. It is an abstract device which is having the two different inputs, x and y. It is having the two different inputs, x and y, such such that when these two inputs are being given to this particular box. Now I shall explain that what is the significance of this box. That then we can be able to get two different outputs, x prime and the y prime. So the comparators are of two types. They are either increasing comparators or the decreasing comparators. So if it is increasing comparators, then they are being denoted by this plus, by this circuit plus operation. Similarly, when this x and y value are being given, then the minimum value will be saved into this x prime, while the larger value will be saved into this value y prime. So, so as I explained earlier, that this rectangle is to be replaced with this circle plus, with the circle plus, such that this circle plus uh, this circle plus will be there at this position, and this increasing comparator is being denoted with this particular figure, such that x and y are two arbitrary values, and x prime will give the minimum value while the y prime will give the maximum value. Similarly, with respect to the decreasing comparator, it can be denoted with the circle negative, where where on giving the input x and y, x prime will give the value, x prime will give the maximum value, while y prime will give the minimum value. So as I explained earlier, it is the notation of decreasing comparator is circle negative sign. So here this is the symbol for the decreasing comparator, such that x prime is having the maximum value while y prime is having the minimum value. Now I shall explain about the significance of the comparator into the next slides. Now before that I want to explain, I want to emphasize that if the value of x is 4 and the value and y is 5, it is being given to the increasing comparator, then the x prime will have the value 4 while y prime will be having the value 5. Similarly, if for the decreasing comparator, if the value of x is 4 and y will be having the value 5, and y is having the value 5, then x prime will hold the value 5 after the completion of the decreasing comparator operation, and the y prime will hold the value 4. So in this way, the values are being swapped by the increasing comparators and by the decreasing comparator.